You probably think the most important discoveries happen when someone is working at their absolute best. You imagine a genius in a spotless lab, focused, organized, every move perfectly planned. You picture polished glass, neatly labeled bottles, and a mind that never forgets a single step as it marches toward a breakthrough. You do not picture a distracted scientist leaving a dirty Petri dish in the corner for weeks. Yet your life has been shaped by that forgotten dish. Today, if you cut your finger on a rusty nail or come down with a severe throat infection, you expect an antibiotic to fix it. You sit in a clinic, you get a prescription, you swallow a pill, and you move on. The ritual feels so ordinary that you barely notice it. But less than a century ago, that tiny pill did not exist, and a small scratch could quietly end a life. Can you imagine walking through your day knowing that even a minor infection might be the last thing you ever feel? To understand how radically your world shifted, you have to step back into the early 1920s. Hospitals smelled different then. Antiseptics were harsh, surgeries were brutal, and infections were everywhere. Once bacteria got into a wound, there was often nothing left to do but watch, pray, and hope the patient did not slip away from sepsis. In maternity wards, seemingly healthy mothers died days after childbirth. In military clinics, soldiers survived bullets only to be killed by pus-filled infections that crawled through their bodies. How would you move through that world, knowing that a blister on your foot could mean a funeral? Scientists tried almost everything. They used dyes called sulfonamides, which could slow down some infections but did not work for all. They experimented with metal-based treatments like silver and mercury that often poisoned patients almost as much as they helped them. They irrigated wounds with antiseptic solutions that burned and scarred healthy tissue. In that landscape of half-measures and heartbreak, the idea of a drug that could quietly kill bacteria inside the body without harming you sounded almost like magic. One of the people surrounded by this constant battle was Alexander Fleming, a bacteriologist at St. Mary's Hospital in London. You can picture him in the summer of 1928, in a cramped laboratory stacked with glassware and culture plates. His bench was famously cluttered, with Petri dishes left in uneven stacks, notes scribbled on scraps of paper, and experiments overlapping one another. Later, biographers like Gwyn Macfarlane, in his study Alexander Fleming, The Man and the Myth, would argue that this supposed untidiness was exaggerated into legend. But even stripped of myth, you can still see the truth. Fleming's lab was a place where order and mess lived side by side. That August, Fleming was studying staphylococci, the bacteria that can cause boils, throat infections, and dangerous blood poisoning. He spread them carefully onto Petri dishes containing nutrient jelly, planning to test different substances against them. Then he did something very ordinary. He went on vacation. He stacked the plates, left them near a window, and walked out of the lab, not knowing that London's air was about to deliver something extraordinary. How many times have you left a project half-finished on your own desk, certain it was nothing special? While Fleming was away, microscopic spores of a mold floated through the air and landed on at least one of those dishes. They began to grow slowly, forming a fuzzy patch of penicillin mold. The bacteria around them multiplied too, turning the jelly cloudy as they swarmed across the surface. By the time Fleming returned, several weeks had passed. The plates should have been useless, contaminated, ready for the trash. Would you have bothered to look closely at them? Fleming almost did not. According to his own later accounts, he was about to discard the plates when something caught his eye. Around the mold colony, there was a clear halo where the staphylococci had simply vanished. The bacteria farther away were thriving, but near the mold, they had dissolved into nothing. The contrast was sharp, almost like an invisible fence drawn in glass. In that moment, Fleming saw something that anyone else might have missed. How many times have you swept past small oddities in your own life, telling yourself they are accidents that do not matter? He did not call it a miracle. He called it a clue. Fleming began to test the mold more systematically. He grew it in different containers, filtered the liquid, and dripped it onto other bacterial cultures. Over and over, he saw the same pattern. The mysterious substance released by the mold destroyed many harmful bacteria but left animal cells unharmed. He named this substance penicillin, after the penicillium mold that produced it. In 1929, he published a paper in the British Journal of Experimental Pathology describing what he called a potent antibacterial agent from this improbable source. Yet in those early years, almost nobody cared. The problem was not in the idea, but in the chemistry. Penicillin was unstable. It broke down quickly, and Fleming's lab could only produce tiny amounts. The paper drew a few polite nods, then mostly faded into the background noise of scientific literature. Fleming himself moved on to other research, never quite solving how to turn his odd laboratory finding into a usable medicine. If you had been watching from the hallway, you might have thought you had just seen a great discovery die in silence. How many powerful ideas in your own life have slipped away because they were too difficult to develop at the time? A decade later, in the late 1930s, other eyes returned to Fleming's forgotten work. At the University of Oxford, a team led by pathologist Howard Florey and biochemist Ernst Boris Chain began hunting for substances that could kill bacteria in the body. Florey's group dug into old papers and stumbled across Fleming's 1929 report. Chain, fascinated by the idea of a mold that secreted a selective toxin against bacteria, pushed to investigate it. This is where your story of that messy plate turns into a coordinated, almost desperate engineering project. Florey, Chain, and their colleague Norman Heatley set up a production line for penicillin in the most improvised ways. Because the mold grew best on shallow surfaces, they poured growth medium into bedpans and food tins, stacking them wherever they could find space. Workers in the lab collected the golden brown broth, then painstakingly extracted penicillin with solvents, trying not to lose its delicate power. A 1940 paper in The Lancet by Florey, Chain, and their team described how this purified penicillin protected mice from otherwise lethal infections, marking one of the first clear demonstrations that Fleming's substance could save lives. The next step was terrifying and simple: try it on a human being. In 1941, the Oxford team treated a policeman named Albert Alexander, who had developed a severe infection after a scratch from a rose thorn on his face. His wounds oozed, his eyes were swollen, and conventional treatments had all failed. They began injecting penicillin into his bloodstream. Within days, his fever dropped and his condition visibly improved. For a while, it looked as if the forgotten mold from Fleming's desk had reached through time to pull this one man back from the edge. Then reality intruded. The supply ran out. There was not enough penicillin in the world to finish the job. Alexander's infection returned, and he died. You might imagine that this was pure tragedy, but in another sense, it was a signal flare. The partial success showed that penicillin could work inside the human body. It just needed scale. The Second World War was raging, and infected wounds were killing soldiers as surely as bullets. Governments in Britain and the United States realized the potential impact of this drug. They poured money and industrial muscle into production. Pharmaceutical companies like Pfizer experimented with deep tank fermentation, growing penicillium in massive vats instead of lab dishes. The yield rose from milligrams to kilograms. By D-Day in 1944, penicillin was being used widely in Allied field hospitals. The statistics from those years are chilling and clear. Soldiers who would previously have died from infections of the blood or lungs now survived. Amputations decreased. Recovery times shortened. Families received letters from sons and brothers who, in another timeline, would never have made it home. You move through a world shaped by that invisible shift, even if you hardly ever think about it. How often do you stop to consider that something as unremarkable as a pill bottle has rewritten the odds of your survival? After the war, penicillin spilled into civilian life. Surgeons became more confident. Doctors took on riskier procedures, knowing they had powerful tools against infection. Childhood illnesses that once hovered at the edge of fatal now lost much of their sting. By the 1950s, a whole family of antibiotics had joined penicillin, expanding the arsenal against bacterial diseases. Today, you casually swallow these descendants to treat everything from ear infections to pneumonia, rarely wondering who first saw a clear ring around a fuzzy mold. But the story of penicillin is not just a cheerful march from problem to solution. It is also a lesson about how you use power once you have it. As antibiotics became cheap and abundant, they were prescribed for minor complaints, even when not strictly needed. They were fed to livestock to promote growth. They were used as a safety net instead of a last resort. Bacteria, constantly evolving, began to develop resistance. A 2015 study in The Lancet, led by researcher Ramanan Laxminarayan and colleagues, warned that if antibiotic misuse continued, the world could face a post-antibiotic era, where common infections once again became deadly. Already, hospitals report strains of bacteria resistant to multiple drugs, including some derived from the original penicillin molecule. These superbugs turn routine surgeries into risks and transform once manageable infections into complex battles. You stand at a strange fork in history. On one side is the world before Fleming, where people died from paper cuts and infected splinters. On the other side is a possible future that looks disturbingly similar, not because you lack knowledge, but because you used it without restraint. How will your choices tilt the balance? When you zoom out, the pattern becomes clearer. Fleming's discovery began as an accident, but it did not stay that way. It took a mind trained to notice anomalies, a willingness to follow up on curiosity, and a series of other people ready to push that idea through years of grueling, unspectacular work. Howard Florey, Ernst Chain, Norman Heatley, and the unsung technicians in their lab were just as essential as the moment of mold landing on the plate. So were the factory workers who tended fermentation tanks and the clinicians who tested new ways of dosing patients. How many times have you seen only the flash of a discovery and missed the quiet army that carried it into reality? You also see how stories warp over time. Popular accounts often turn Fleming into a lone hero, a forgetful genius whose messy habits magically rescued humanity. Historians like Gwyn MacFarlane have shown how that tale oversimplifies a far more complex web of credit and effort. The real lesson is not that you should keep your workspace untidy, hoping for a miracle. It is that when chance hands you something odd, your response matters more than the accident itself. Do you shrug and sweep it away, or do you lean in and ask why it looks so wrong? In your own life, you probably have your own contaminated plates. The draft you abandoned because it seemed flawed, the half-finished project gathering dust in a folder, the strange result in your work that did not match your expectations, so you quietly ignored it. Every one of those moments carries a question. What would happen if you returned, looked more closely, and treated the flaw as a signal instead of a failure? How many discoveries in art, science, or your personal growth are hiding in the corners you have already written off? The story of the Petri dish Fleming forgot is not just about penicillin. It is about your relationship with imperfection and chance. It shows you that breakthroughs do not always arrive when you are prepared, polished, and in control. Sometimes they arrive when you are already thinking about vacation, when your bench is a mess, when your attention is somewhere else entirely. The difference lies in whether you are willing to see the halo around the mold, to recognize that an untidy accident might be the doorway to a different world. So the next time you glance at your cluttered desk, your overfull inbox, or the notebook with the strange, abandoned idea, remember this arc. A tiny spore drifted into a dish. A tired scientist noticed a clear ring instead of a blur. Other minds, years later, refused to let that observation die. Factories roared, hospitals changed, and your odds of surviving a simple infection quietly soared. You owe part of your ordinary, everyday safety to a chain of moments that began with a mistake and ended with persistence. You probably think the most important discoveries happen when someone is working at their absolute best, but now you know how often they begin when someone is nowhere near their best at all. If you liked this video, do like and subscribe to this channel. Comment below on which scientist would you like to watch next.